Okay, so just want to talk about the area right between the curve today for calculus. The way to find the area right between two curves or under the curve. And also I would like to talk about the disk method and also for the washer method for finding the volume of the three-dimensional irregular solid. So let's start it off with the area of two curve formula. So as you can see that here. So the area of two curve, so when it's considered area integral from a to b of f of x minus g of x, so integrated with respect to x, where f of x is the upper curve and g of x is the lower curve. So the graph showing that f of x, which is right above the g of x, and integrating it from a to b. And then the other one, the alternate form, it's the sideways curve. So this one we'll talk about like the right hand curve, so which is f of y, subtract g of y, the left hand curve. So in order to find the boundary, sometimes you have to find out the point where they intersect, like point D right there. So from the lower bound to the upper bound, so C to D. So once you integrate the difference of f of y minus g of y, integrating it with respect to y, so you'll get the area right between those two curves. So now the next one I'm going to show is the example, the way to apply the concept, the formula. Okay, so we'll take a look at that, the first one. So sketch the region enclosed by the given curve, and then decide whether to integrate with respect to x or y, then find the area of the region. So first thing that you want to do, you want to set up the graph, sine of x, which is a roller coaster, and y equals e to the power of x, that's the exponential growth functions. So sine of x, and then e to the power of x. So it's going to be something like this. Now the thing is that it shows the boundary, so it goes all the way from 0 to pi over 2. So that means we need to find out the area of the shaded region. So you may notice that the upper curve, which is e to the power of x, and then the lower curve, which is sine of x. So we started with that f of x, integrals of f of x, which is e to the power of x, minus sine of x. So integrating it from 0 to pi over 2, and then the indicator, which is dx. Okay, so that's just a setup. And now, you want to find out the integrals of e to the power of x, which is e to the power of x. Integrals of sine of x, well, it's negative sine of x, so then that would be positive cosine of x. And then integrating it from 0 to pi over 2. So now we're using f of b minus f of a, so part 1 of ftc. So e to the power of pi over 2 plus cosine of pi over 2. And then minus e to the power of 0 plus cosine of 0. So e to the power of pi over 2, nothing we can do about it, just leave it. So cosine of pi over 2, which is nothing. E to the power of 0, then that's 1, so it's minus 1. And then cosine of 0, which is 1. So negative, negative, so minus 1 again. So we do have e to the power of pi over 2 minus 2. So for this exact value, so then that'd be the area right between those two curves, from 0 to pi over 2. So now let's do the one that without the boundary, and also it's a sideways curve. Okay, so to look at that for C. So for C, we do have 4x plus y squared equals 12, and x equals y. So first thing that you want to do, so sketch the graph for that 4x plus y squared equals 12. So, well, one thing that I can do here, I can isolate y by itself. So subtract 4x both sides. So we do have y squared equals 12 minus 4x, and then square root. So we got y equals square root of negative 4x plus 12. And also we can take out the greatest common factor, which is 4. So we got 4 times the quantity of negative x minus 3. And then square root of 4, which is 2. So we got y equals 2 square root of negative x minus 3. Well, the reason why I want to do it this way, because I want to find out the transformation. The value of a, h, and k. So the value of a is 2, which is the vertical stretch. It's a reflected over the y-axis. And also h, which is considered positive 3. Well, because that one should be right, it's 2 times the quantity of negative x plus 3. Well, actually, h is negative 3. It's going to the left. And there's no k, so k is 0. So now, let's sketch the graph. So we do know that's a radical, so it's a radical curve. That means it's half sideways, parabola. So it's negative 3 units. Well, 3 units to the left. K equals 0, so it's over here. And it's reflected over the y-axis. So that means the curve is going this way. Well, one thing that I just want to check here, so if we try to isolate y squared by itself, so we do have y squared equals negative 4x plus 12. So y squared equals negative 4 times the quantity of x minus 3. So that's just another way to come up with the conic sections. So negative, that means facing to the left for the parabola. But the thing is that's a half sideways parabola. So that means going this way. Another thing that you want to put in here, it's that x equals y, which is the line. Okay, so x equals y, so that would be the line right here. And now you want to find out the point where they intersect. So in order to find out the point where they intersect, so you want to set those two equations equal to each other. So we do have y equals square root of negative 4x plus 12, and y equals x. Okay, so we can just set that equal to each other. Another way that you can do it, you can just set x equals 12 minus y squared over 4. And then we just set that equal to y. Because once you solve for y, then that would be the boundary, the lower bound and the upper bound. Okay, so let's just set that 12 minus y squared over 4. So that equals y. So multiply by 4 both sides, so we do have 12 minus y squared equals 4y. And then try to bring everything all together, so we do have y squared plus 4y minus 12 equals 0. And then try to factor it, so we do have y equals negative 6. Well, actually positive 6. And y equals negative 2. And try to factor it. So that means y equals 2, and also y equals negative 6. So that means we need to integrate a graph from negative 6 all the way up to 2. It looks like there's something wrong with the graph right here. So anyway, once we find out the boundary, so we'll set up that the integral. So the integral to set up for this one is the right hand of curve minus the left hand of curve. So the right hand of curve, which is considered the parabola. So what we got here, so you want to solve for x. So we got 12 minus y squared over 4 minus the line, which is y equals x, so minus 1. And then integrating it from negative 6 all the way to 2. And then the rest of this, all you have to do is just integrate it. Okay, so the next one I'm about to show you here, it's about the this method and the washer method. So for this method, so this one is basically finding the area of a circle, so it's pi r squared, so area. But the thing is that we need to find out the radius. The radius normally is determined by the polynomial or the function itself. And then sometimes can be written as a of y dy, integrating it from c to d. Now, but the thing is that we do have two different kind of revolution axes. So one is sideways, which is integrating it with respect to y, and the other one is vertical, which is integrating it with respect to x. So we're going to find out which one is which. So the best way to determine that which revolution axis we're using, or which variable that we're using, it's about the indicator. So the indicator pretty much determines which way that you want to revolve against the revolution axis. So let's say that the x-axis would be the revolution axis. So that means the indicator, it's always perpendicular to that revolution axis. If that's integrating it with respect to y, so that means the indicator, it's always perpendicular to the revolution axis, the y-axis. Okay? So now, let's do one example like this. Okay, let me just report it out. One of the practice problem. So let's just use the exact same problem here. So sine of x, e to the power of x. So the one that we did earlier, that was finding the area run between two curves. And also this one, it goes all the way from 0 to pi over 2. So for the graph that we did earlier, it's about the roller coaster, the sine curve, and the exponential functions. And let's say that the revolution axis would be the x-axis. So it's revolving this way, x-axis. So now, anytime that you're given with two functions like this, and also you do see the gap right between that, the indicator, and the revolution axis. So here's dx. So that means we're getting to radii. So the first radii would be the upper curve. So let's say this one is capital R of x. And then the inner radius, then that would be lowercase r of x. So back to geometry. So let's say that we need to find out the volume of two cylinders, the outer cylinder and the inner cylinder. Okay, something like this. So we do have two radii. So one is the inner radius, and the other one is the outer radius. So the way to find out the volume, it's about V equals pi times h, and then multiplied by the difference of those two radii squared. So capital R squared minus lowercase r squared. So we're using the exact same concept for this. So integral from 0 to pi over 2, and then pi. So for the outer radius, so we do have the upper curve, which is e to the power of x. Quantity squared minus the inner radius, which is the lower curve, and then that'd be sine of x. Again, we're integrating it with respect to x, so dx. And now from here, so you can integrate it. So you may notice that there's no such formula for the integrals of e to the power of x squared. Okay, so you have to do that on the calculator. Okay, but normally they'll give you the problem that which is integratable. But for this case so far, you don't know what those formulas are, so you have to do that on the TI-84. Okay. So what I'm showing here is just a setup, and then the rest of that you can just put it in y1 equals this integral from 0 to pi over 2 times pi, and then you'll find out the exact value. Again, anytime they see those two curve, upper curve, lower curve, it's always considered two radii. So this one is all about the Washer method. Okay. Now, what about for the disk method? The disk method, that means there's only one radius involved. So let's say that we just want to find out the volume. Okay, so let's say it's just a straight line, y equals x. Okay, like that. And then you want to find out the volume of this shaded area from 0 to 5. Okay, so that means this one is revolving around the x-axis again. Okay? So you may notice that, well, this part right here is a triangle, so once you revolve it, so it looks like it's going to be the volume of the cone. Okay? So let's do that. So y equals x, that's the function. So there's only one radius. That means it's integral from 0 to 5 pi, and then x squared dx. Okay, so integrated. So integrals of x squared, which is 1. X to the power 3 over 3 times pi. It goes all the way from 0 to 5. So pi times 5 to the power 3 over 3. So 5 to the power 3, which is 125, so it's 125 over 3 pi. And that's the volume of this shaded region. Again, this one is revolving around the x-axis. So eventually, it's going to be considered a cone. So you may notice that the radius for the cone, okay, so it's about that big. And here's the height, the one that we just integrated. So the radius, which is considered 5 as well, because the function is y equals x. So 5 quantity squared, which is 25 times 5, then we got 125. And according to the volume formula for the cone, it's 1/3 pi r squared times the height. If you just plug in a number, that's exactly what we have. So it's 125 pi over 3. Okay, so now let's do another problem. It's a little bit more complicated. And this one is going to be considered the sideway shaded region, and also we need to find the volume inside. Okay, so let me just set it up right here. So let me just make up one problem. So let's say that 4x equals y squared. And this one is being bounded by also y equals x. And it's revolving around the y-axis. Okay, x-axis, y-axis. Now, you may notice that there's no boundary, there's no C and D. There's no upper limit, lower limit. So the way that you want to start it with to find out the boundary is by setting the equations equal to each other. So we got y squared equals 4x and y equals x. So that means x for this one is y squared over 4. So the first step. So you want to find out the point where it intersects. So we got y squared over 4 equals y. And then just solve for y. So we do have y squared equals 4y. And bring everything together to one side. So we got y squared minus 4y equals 0. Factor it. So we got y minus 4 times y equals 0. So y equals 0, y equals 4. And now you want to sketch the graph. So this one, it's a sideways parabola, and it's facing to the right. And the point where they intersect, it's about right here. Again, this one is revolving around the y-axis. Now you may notice that the right-handed curve is actually the line, and then the left-handed curve is actually the parabola. So that means we're using dy from 0 to 4, integral from 0 to 4. Again, we do have two radii. One is the outer radius, and the other one is the inner radius. So the outer radius, which is the line, so which is y squared. And then for the inner radius, then that would be y squared equals 4x. Again, x equals y squared over 4, so y squared over 4, quantity squared. Outer radius squared, inner radius quantity squared. Then integrating it with respect to y, and then times pi. Again, this one is just a setup, and then the rest of this, you can just basically integrate it, and then evaluate it. And thank you for watching the video today.